Hi guys, so today we'll be talking on the next lecture of our NLP series, and it's going to be about classification matrix. So we have talked about naive Bayes classifier, right? We were able to see how we can classify emails as spam and ham and perhaps anything. So guys, I have seen that a lot of people struggle in this topic, that is classification matrix. That how do we evaluate performance of a model? And I don't understand why. Evaluate performance of a model. So essentially, let's say you built a classifier and someone says, hey, how accurate is it? Then you can talk about that. Hey, it is 90% accurate. How would you calculate that? So essentially, that's the idea of this lecture. And in the in my initial days, even I used to, I'm not sure, at times get confused what is there, what is not there. But to me, this is probably one of the most simple topics, I'll say. And again, guys, we need to move quick so that we reach to a stage where we can start talking about NLP and LLMs. That's where the main magic is going to happen, and hopefully we'll try to create end-to-end excellent NLP pipeline so that we don't need to worry about anything. But guys, this is a very important fundamental topic. You are bound to expect some interview questions from here as well. Just try to stay with me, and whatever doubts you have are all going to be clarified, that's for sure. So guys, see, it's a very simple topic. Okay, first of all, the thing is, we are talking about something known as confusion matrix, right? So what I have done is I have drawn two rows: actual spam, actual not spam, pre-spam, pre-not spam. What is this pre? This pre is predicted spam and predicted not spam. So see guys, what happens is, let me erase all this stuff. So what happens is generally your model comes up with a prediction. Okay, just if you understand this part, rest all you will understand. Now that is called as predicted class. Now the thing is, let's say your model predicted positive. Please try to stay with me, this is very important. Your model predicted positive and the actual answer is negative. So what would this be called? This would be called false positive. False positive. Why? Because the thing is, this is positive. Your model predicted something as positive, but actually it is negative. Therefore, this is a false positive. Why false? Because actually it's negative. Why positive? Because it predicted positive. So it's a false positive. This is the analogy. So if the model has predicted something as spam and actually it is spam, so it's true positive. If your model has predicted something as not spam, okay, something as not spam, but actually it is a spam, so it's a false negative. So our model has predicted not a negative class, not spam, but actually it is spam, so it is false negative. What is false positive? Your model has predicted something as spam, so it's predicted positive, but actually it's not spam, so it's false positive. And true negative is actually not spam and predicted not spam. I guess you understand this, guys. The trick to remember this is, whatever model predicts, just try to make sure that whatever the model is predicting, if it predicts positive and the actual thing is negative, so it's a false positive. If it predicts negative and the actual thing is positive, okay, so it is a false. It has predicted negative and actually it is positive, so it's a false negative. Guys, now I hope you understand. Okay, so usually these terms, if you listen to news during COVID days, these term got famous in context of RT-PCR. So people used to claim, hey, this has higher false negativity rate or higher false positivity rate. I don't remember, but I'm just giving you reference. Done. Now, what is the formula for computing accuracy? So computing accuracy is that you add these stuff diagonally, TP plus TN, and divide by all those four things which we have. So you will create a model and you will create this confusion matrix. Guys, everything is super easy. In Python, it's just 1 to 2 lines of code. Don't worry, the coding part is not difficult. The system design is difficult and understanding basics is difficult. If you believe coding is difficult, guys, try. I also have a video on my YouTube. Try using cursor. You will realize that what would be the future of coding. So just relax, okay? Just try to understand the basics and we'll slowly go to system design as well. So just chill. Now the thing is, your model would have, you make this confusion metric. Let's say your model predicted 50 true positive, 10 false negative, 5 false positive and 100 true negative, and then you compute the accuracy and you say, hey, I've got an accuracy of 91%. So this is what is accuracy. But guys, tell me one use case. Let's say I have a data in which 99% of the data set is of one class and 1% data set is of 0, and I always predict the majority class, that is 1. So what would be the accuracy of the model? The accuracy of the model would be 99%. Then tell me guys, will this make sense? Even anyone who hasn't trained any ML model or anything can just maybe predict this as 1 and get this stuff done, right? So just try to understand that for most classification based workloads we don't use accuracy. We go to two important metrics, precision recall, and from precision recall only, the harmonic mean of precision and recall is nothing but F1 score. Okay, now the thing is that what is precision? So precision's formula is true positive plus false positive, okay, ratio of correct positive divided to the ratio of total positive prediction. So this is also positive, this is also positive, right? What is false positive? False positive means your model has predicted something as positive but that's not positive. And then you have recall, true positive divided by true positive plus false negative. Okay, these are actual positives in the denominator, you would understand. And for F1 score we take harmonic mean. Okay, now for the time being you can like skip these terms, micro average and macro average. I will talk to you when we need them, but just remember these are the type of matrix which some people look in multi-class classification. Okay, most people wouldn't have even heard about these terms, but that's okay since we are talking about things at an in-depth level, so I'll tell you. Now you would be like, sir, I understand accuracy, but this concept is just mathematically clear. Guys, don't worry, we'll study about micro macro average as and when we require, because those are very simple concepts. But the main thing is understanding this concept. Okay, this is what is business use case you will be using. Okay, formula guys you can remember. Okay, now you know what TP is, you can memorize them, right? You don't need to memorize them guys. Before interview maybe do it, otherwise just skip it. Everything is there in the internet and the LLM. So now the main thing is, sir, what is its implication? That is the main part of this lecture guys. See, understand. Let's say first of all, let me use a complete new sheet. Okay, I'll write it from scratch for you guys. Let's say you're training a spam ham classifier. Just stay with me guys, this is very important. This is where 99% people get confused. Spam ham classifier, and books also just confuse you. The thing is, what are we trying to predict? We are trying to predict a system that whenever an email will come, it would be either predicted as spam or it would be either predicted as ham. Now just try to understand guys, what is spam? Spam is something that's not good, right? So some people call it negative and ham as positive, so this is our positive class. But guys, you know, this type of annotation is usually, I would say, see, nothing is incorrect and correct, but just understand the reference point. Usually what happens is the class of interest. What is the class of interest? Class of interest is spam. So this becomes your positive class and ham becomes your negative class. It's just a way of writing things, right? You can do it this way as well. Okay, but usually what researchers do is that the class of interest is considered as positive and class of non-interest is considered as negative. So now you want to create a spam ham classifier, and considering that spam is my positive class because that's the class of my interest and ham is negative class, an email comes, okay, and that email is ham and that gets classified as spam. So it is a what is it? It's a false negative, right? Now you need to now tell me, guys, is it good? Let's say there is such an important email that has come and you have classified that as spam. So that is a false negative. So let's say you're trying to create an spam ham classifier, then you need to look at precision. Okay, wait, this is false negative. Let me try to revisit it once. So an email came and my system classified it as ham. That means it has classified it as negative, but actually it is positive, right? So it is more like false positive. No, it is like false negative. Let me just try to see once. False negative, false positive. Okay, guys, allow me 1 second. Let me just try to revisit the formula once. Maybe I'm missing something. Yeah, guys, no, let me retry to create the situation. Okay, let's just revisit it because I believe that my basics are strong, so I won't get confused. Okay, formula and all can get confusing, but I trust my basics. So an email came and it it is a ham. Actually, it is a ham. So my actually it is ham. So it is negative, but my system predicted it as spam. So this is a bad scenario because an important information got classified into spam. And then this is my positive class. Why this is a positive class? Because this is class of interest. So the thing is this becomes a false positive, not a false negative. Right here I wrote, see guys, see how did I clear my concept? I just cleared my concept because I trust my basics, right? I didn't look anywhere. I'll tell you the truth, whenever I am delivering a lecture I don't look at anywhere. You can even check from the clock time how much time I paused the video. It must have been under 1 minute. I don't see anywhere because I believe my concepts are rock solid, so I can scale them up whenever I want. See, an email came, it got classified as ham. It in actually it is a ham, but my system is bad. It means it's not a good system. It predicted it as spam, so it has predicted a false positive. What is a false positive? That actually false positive means that the outcome is negative, but my model has predicted it as positive. Why positive? Because as I said, guys, from the point of view of reference, it just depends upon reference. From the point of view of reference, whenever we are training a spam ham classifier, so spam is considered to be positive class since it is a class of a reference. So in that case, see, we want to have a system in which false positives are minimized. So whenever we want to have a system where false positive is minimized, I go for precision. I want a model which has a higher precision. Okay, now let's move to another example. Okay, everything will be clear, guys. The other example is let's say you're training a system. Let's say you're training a system. Let's say you're training a system which will predict that whether a person is diabetic or non-diabetic. Now this diabetic becomes positive and this becomes negative. So let's say your system is not working properly, so a person who is diabetic gets classified as non-diabetic. That means your model predicted wrong, so it will become a false. What it predicted non-diabetic, but actually the person is diabetic, so it is a false negative. So if you want a system where false negative are reduced, right? You would want a system in this case where false negative are reduced. You would go with recall. See, Fn is there. And whenever you want to have a balance of both the situations, go for F1 score. For the time being, you can just remember this is 2PR divided by P plus R. This is harmonic mean. There is an implication of AMGM HM inequality which results in the fact that why this is harmonic mean, but we can skip that maths. We don't need to go in depth of it. So guys, in simple terms, let me just give you a concluding note. In concluding note, that is, whenever you train a classifier, you would need to compute something known as confusion matrix. I have shown you that. Okay, matrix. And based on that, you need to look at accuracy, F1 score, okay, recall and precision. Recall and precision. I have given you examples for recall and precision in games of spam ham classifier and diabetic prediction as well. See guys, even as I said in the lecture only, there are people who get confused, and even I for a moment missed this point that by mistake I wrote false negative, but all it took me is 1 second to get the system clear. See why? Because I understand the basics. So if you just follow along with me in this playlist, subscribe to the channel and just try to revise this lecture, I can bet you will never be confused in confusion metrics. So okay guys, have a great day ahead. Please subscribe.